This is like the third time I've tried to record this, and so just bear with me. I've said this like 1,000 times already. So there are a few ways that alpha helices can be held together. So, for example, one example is ionic bonds, another one is hydrogen bonds, another one is hydrophobic interactions, and also disulfide bonds. So for our example, the leucine zipper, what's holding the alpha helices together in this example is the hydrophobic interactions between the leucine molecules and the electrostatic interactions between lysine and glutamate. So starting off talking about the hydrophobic interactions in general, they stabilize a complex because hydrophobic amino acids like to aggregate together to stabilize it and also to be protected from the outside aqueous media or environment. So, which is like opposite from hydrophilic interactions. So, but then the main idea behind the electrostatic interactions is that amino acids with opposite charges will attract each other. So when you have an amino acid with a positive charged side chain, amino acid with a negatively charged side chain, they will come together instead of repel. So for this example, lysine has a positively charged side chain, and glutamate has the negatively charged side chain. So when thinking about what kind of another residue that could replace leucine and still have the same effect that it does, you should really think about a hydrophobic amino acid, but specifically isoleucine, because for just reason they have similar R groups. Well, the R groups are isomer. Sorry, their side chains are the same length, and they have similar masses. And isoleucine is also hydrophobic, like I just said. So just to give a visual example of that, this is from the textbook on my iPad. So you see leucine and isoleucine, and they're the same length, and they're 4-carbon side chain, and you can just see that from here. So that's something of a visual explanation of that. So, and when thinking about what could destabilize the core complex, really any hydrophilic residue could, because hydrophilic amino acids don't want to be they don't want to be aggregated, and they don't want to be protected from an aqueous environment or medium. They want to be exposed to the medium. So just really any hydrophilic residue could. So I just chose serine to say as an example. And so when thinking about, what was the last part of the question? So I'm thinking about an amino acid pair whose side chain would interact similarly to lysine and glutamate, so that lysine has a positively charged side chain and glutamate has a negatively charged side chain, and that's how they interact. You can really just choose any positively charged side chain and negatively charged side chain. So I just chose aspartate, which has, as you can see, it has a negatively charged side chain, and I chose arginine, which is right here from the textbook. It has a positively charged side chain, and they would interact in a similar way because they have opposite charges, which would attract them to each other instead of repel them. So just to recap, for the leucine zipper, it is the hydrophobic interactions between the leucine molecules and the electrostatic interactions between lysine, which has a positively charged side chain, and glutamate, which has a negatively charged side chain, which are holding the alpha helices together. Okay, bye.